All right, so let's see how my videos are doing. Wow. What was I thinking making that 22-minute video about innovation in the new space industry?
We'll talk about...
We got to make shorter videos, huh? So here's 3 minutes on the clock. Let's go. At its core, a rocket engine subsystem consists of the rocket engine, the thrust chamber assembly and nozzle, and a set of tanks for storing and supplying the fuel and oxidizer. These propellants are pressurized and fed into the combustion chamber of the engine via suitable plumbing and burned to produce thrust. Higher the pressure in the rocket engine combustion chamber, higher the thrust. The liquids are expelled directly from tanks via high-pressure gas, or they are delivered via turbopumps to the chamber. And this is what we'll be focusing on in this video. One of the easiest power cycles is the gas generator cycle. In a gas generator cycle engine, a small amount of fuel and oxidizer is burned in a separate combustion chamber. These exhaust gases are then used to spin a turbine, which in turn turns the main pumps. This is an open cycle type engine, meaning that the working fluid used to power the turbine of the pump is discharged overboard after having been expanded in a separate nozzle. This often means that there's a loss in propulsive efficiency, as not all of the propellant is available to produce thrust. Some examples of gas generator cycle engines include the Merlin 1D engine used by SpaceX. That's when we start looking into closed cycle rocket engines like the expander cycle and the staged combustion cycle. In the expander cycle, fuels with relatively low boiling points are fed through the nozzle walls of the combustion chamber. During this process, the fuels like hydrogen evaporate into a gas and then is fed into a low pressure ratio turbine. After dumping a bunch of energy to the turbines, the flow is then redirected to the injector of the rocket engine for further combustion. Examples of expander cycle engines include Relativity's Aeon-1 engine used to power the Terran 1 vehicle. Another type of closed cycle rocket engine is the staged combustion cycle. While an expander cycle type engine does not feature a gas generator, a staged combustion cycle engine consists of a pre-burner or a high pressure gas generator that burns all of the fuel with a part of the oxidizer in the case of a fuel-rich combustion cycle, or all of the oxidizer with a part of the fuel for the ox-rich staged combustion cycle. The exhaust is then used to drive a turbine to spin the pumps, but post-turbine, the exhaust products, which contain all of one propellant and a part of the other, are plumbed into the main engine chamber via the injector. Here, mixture A meets with the remainder of the other propellant to complete the combustion process. Since this is a closed cycle, all of the propellants are fully burned in the engine combustion process. Propulsive efficiencies tend to be way higher. A cool variation of the staged combustion cycle is the full-flow staged combustion cycle, where both fuel-rich and ox-rich systems are combined and used in parallel. This results in propellants being injected into the injector in a gaseous form, leading to very high combustion efficiencies from the gas-gas mixing. Examples of staged combustion cycles include Ursa Major's Ripley rocket engine, as well as, of course, the SpaceX Raptor rocket engine. And as a special mention, I have to talk about Rocket Lab's electric propulsion cycle powering the Rutherford. And time's up. I guess this one will have to wait until next time.